Hello. Welcome, everyone, to Vendor Vortex, uncovering hidden threats in third-party software. My name is Tom Pohl. I'm the principal consultant at LMG Security, as well as the penetration testing team manager. LMG Security is a cybersecurity company out of Missoula, Montana. And with me today, I've also Derek Rowe.
Hello, everyone. I'm penetration tester over at LMG Security as well. One of my main focuses are going after vulnerabilities, identifying them in different types of software. And including in that is third-party vendor software. And well, just to spoil it, we're going to show you a few examples today of that.
But before we get started, I want to make this talk very interactive. I love when we have back and forth dialogue with the audience. So if you have a good question, we only have a few left, I think 4. But if you ask a good, interrupt me anytime, interrupt us to ask a good question, we've got shot glasses we'll throw at you. So I encourage you guys, I want this to be a discussion, a dialogue. I love the back and forth because, some of this stuff is scary and you'll see it on your networks and you want help. And we're here to help and talk about it today. So anyways, good questions lead to good shot glasses. So let's get going. In every one of your white bags that you got, you have a card with a key on it. And that key might unlock a treasure chest down at our booth downstairs. I know we're giving away every key that unlocks something. We're giving away a drone. And I think we've still got one left to give away. So check. Did they give them all away? I don't think so. There's one left. Yeah, Matt says there's still one left. So if you haven't checked your key at our booth, the chances are pretty high at this point that you might have won a drone. So go ahead and go down there and do that later. Anyways, so why are third-party vendor vulnerabilities important, right? So often we're running lots of software that we didn't create on our infrastructure, on our networks, and they can be opening up vulnerabilities that can compromise our organization. And often we're installing software that we just blindly trust, right? And maybe they'll come out with a patch or so forth, but we should really look at our software that we're installing critically with a critical eye and say, gosh, do we really need that? Do we really need to do this thing? Or do they even realize that, installing a piece of software actually exposes things that the vendor may not even tell you that they're exposing? And so we're going to show you 4 real world examples of vendor vulnerabilities and what we've seen in the wild. And so these aren't like, hey, maybe this is a thing. This is like what we see on our penetration tests with other organizations that are alarming and that we should all be worried about.
Yeah, absolutely. Thanks for going over that, Tom. So to begin, our first example, this is, so to start off, what our most important thing whenever we get ready to do an engagement is enumeration. Oftentimes, this is using nmap so that we can discover what services, what ports, what versions are. And so that's what you're looking at here is we were able to actually see a Power Panel login interface can you hear me? Through our enumeration. And all we had to do is simply bring it up over our web browser. And that's what we're looking at here. Just to fill a little context on what this Power Panel really is, a UPS, it's essentially it's a device that's going to provide backup power to keep your electronics running if there happens to be any kind of power outages or any kind of business operations on the electrical front. So first thing we check whenever we find a login interface such as this is default credentials. And Tom, you probably can attest to this. Maybe once every engagement?
Yeah, every engagement, you're going to have something on your network that's probably got a default credential still, right? I see this in organizations all the time. Like maybe you've got you've got 6 printers. They're all configured exactly the same. They all showed up with your lease at the same time. And then eventually they're like, oh, wait, we need another one. And so you'll add a 7th printer and it doesn't go through the same change management process as the first 6, right? And somebody forgot to change the default password on that one. We'll see this kind of a thing in organizations all the time where they're trying to be diligent in managing things like a default credential, but you don't always get there, right? And so unless you're in your network testing these things, I would argue, especially with the new California laws, default credential is a vulnerability, right? It is no longer okay for a device to come from the manufacturer with a credential that you can literally Google and find the answer as to what the default login and password would be for a device. And so that's what we did here in this particular case was we Googled, hey, what I don't think I've ever seen this product on a network. Usually it's like Schneider Electric or APC or something like that. Mm-hmm. And so it's like, what is the default credential for this particular device? And we found it. In just a Google search way, you don't even have to click on a link. You just Google, hey, what's the default password for this? And they're like, here you go.
Oh, absolutely. And so we were able to use admin to be able to gain access to this interface. If you want to jump to the next slide here, perfect. Did you want to go over exactly what we're able to find?
So once you get into the device, it's like, what is it that we have access to? And in this particular case, often with a uninterruptible power supply, sometimes you've got access to turn devices off. Sometimes you have information. So we'll often want to glean as much information out of these interfaces or take advantage of their positions in the network in order to gain more access to an organization. So typically when we get into something like this, it might have like, hey, it's going to send email alerts, right? So when the power goes out, it's going to try to let somebody know something's wrong, or if there's a battery failure or whatever it is. So there might be credentials there in order to send email. There might be SNMP community strings so that we could gain more information by using those, trying to reuse those community strings on all the other network resources on the network. Whatever it is, we might try to elicit or even, doing what's called a passback attack to get a credential from a device because to relay it over to us so we can gain access to a password. But in this particular case, it was a little bit easier than that, wasn't it?
Yeah, actually, essentially all we had to do is highlight this text on the password text box down here and right-click it to reveal password. So what we're looking at here is this is a vCenter login within the service infrastructure management settings. But somebody lost it along the way and forgot to go back and delete it because it was still saved there whenever we came through doing our test.
Yeah. So what's important is that like this device needed to be able to log into vCenter, right? Mm. So if the power went out, it could go log into vCenter, gracefully shut down all your virtual machines before the power ran out. And so it had credentials in the power panel, but the problem is that you shouldn't be able to get that credential out of the web interface, right? Most printer manufacturers have fixed this, but apparently Cyber Power, yeah, that's what it was. Cyber Power didn't do that. You could literally right-click reveal password, and now you've got a username and password to vCenter for vCenter operations.
Or so we thought.
So we went ahead and tried those credentials out, and it turns out this must be an old, out-of-date piece of software because we couldn't actually use that username and password to log into the network or log into their vCenter, which is a good thing, but it was a really juicy password, right? So this looked like a password that should work somewhere because, the way that this organization was set up, it just looked like, okay, where can we use this password elsewhere? So we actually went to their Active Directory domain controller, and we used a technique called anonymous SAMRPC. So we went to the RPC service of the domain controller, and literally you pass it no username and no password and say, give me all the users. And it's surprising recently, I'd say in the last 6 months, 40% of organizations that we've tested have anonymous SAMRPC available, where you can just say, hey, give me all the users, and it'll literally give you every user. And you can not just get users, you can get group enumeration, machines, a lot of even password policies. So like if I want to do password spraying against your organization, I know how many tries I can get against your domain controller without locking out a user. And so, using that information and using that password, we went ahead and did what's called a password spraying attack. So we basically, with that username list and this really juicy password, we went ahead and hit every user in the domain until we get success. And it looks like Jessica in this particular, all of our screenshots, by the way, are completely redacted. Sometimes you'll see that because these are real examples from real networks. We'll redact everything so you can't tell where this is from. It wasn't actually Jessica that was in the user, but we had a user that used that same password on their network. And then actually that was a domain administrator password, right?
Yeah.
So then at that point we could take control of their entire network and access any resource on the entire organization that we wanted to.
Super incredible. Super incredible. As far
There's
as
example number one, like literally, I'd say there's actually two vulnerabilities there, right? One is one that you can mitigate, default credentials, right? The second one is one that the manufacturer has to fix, right? And so that's you shouldn't be able to get a password out of a web interface for a management device. So
yeah,
yeah,
totally agree.
terrible things.
Terrible things. So moving on to our next one, we promise we're not just picking on Power Panel. But as you can see, this is a different Power Panel. This is Power Panel Enterprise, it looks like. So different version.
Different client.
Different client, yeah. Thank you. But once we enumerated this actually able to discover that it was vulnerable to TE 2023-3265, which was actually talked about. It was a talk during DEF CON.
DEF CON last year.
Yeah. Last year, yeah.
Yep.
And so we were super excited to get to try this out and test drive that CVE, see if we could crack it open. Let's dive into that a little bit. What exactly is that vulnerability? The vulnerability that we were able to find on this, again, the CVE, is actually a hidden option labeled L, and you're able to actually see it once you open up the inspector tool, as you can see here, and just take a look and see the display none option. So we take a look at that and we're following this, proof of concept. What happens if we were to change that to something other than none? So essentially that's what we did.
Yeah, we switched it to block and all of a sudden a login control pops up on the page, right? That has two options, right? System, local system and LDAP. And so it's amazing, right?
Yeah.
All you got to do is choose LDAP, hit the login button. Guess what happens? You're logged in. You're an admin now. You didn't even need a password, let alone a default password. So they didn't have a default credential there, but we didn't need a default credential. We just tricked the login page into thinking that we're trying to log into LDAP, and because LDAP wasn't actually configured on it, it let us bypass the entire authentication process, and now we're into the device as administrator. Again, what is it that we're going to try to do? First time we get into a device like this, we're going to try to get as much information out of it as we can. So we're looking for, opportunities to get other information. In this particular case, it didn't have much information in the interface, but what it did have was a way to back up the configuration. And so this is interesting, not because we could get a backup of the configuration, but because you can actually specify where do you want the backup to be stored. And often they'll be like, oh, do you want to store on the C drive or the D drive or wherever, or you can even put it on a UNC path to a network share. But one of the other vulnerabilities that excuse me, this thing's kind of flaking out. One of the other vulnerabilities that was discovered around the same time as this LDAP vulnerability was basically a command injection vulnerability. And so actually I dug into their proof of concept, and their proof of concept didn't actually match up what we know worked with this particular web interface, because it was base 64 encoding both username and password, but it wasn't base 64 encoding the storage location. And so what I did was I captured the request to the server with burp sweep, and you can see here I changed the storage location to put a single quote, space, and then a PowerShell command that then grabbed a PowerShell script from attacking server that I controlled and then executed. So download and execute. So IEXIWR. And then I grabbed TomShell.ps1. And what happens on the back end, if you look at the source code, is that it's stringing all these variables together and then running it as a command on the system, which is terrible. Is anybody here familiar with SQL injection? How does SQL injection work, right? You're stringing strings together, you're doing a query against the database. This is just like that, except you're stringing strings together and then you're executing as a command. And so what I did was I terminated one command, ran my own command, and then allowed it to continue on with whatever it is it was trying to do. So I injected my own command into the middle of this execution process. And what does that give me? It gives me a reverse shell. And so what a reverse shell is basically this PowerShell script downloaded a program and then opened up a command prompt that let me remotely control the command prompt. And so, so my first rule of thumb is like, let's create a local administrator account, because who is this running as? It's actually running as NT authority system. So it's local admin of the host. And so one of the things that we like to do if we get a local system access onto a box is let's create our own local administrator account. So we created our own, and these are the commands here that we ran, were to create our own LMG admin account and then add that local admin account into the local administrators group. And what do we do that for is because so then we can connect to that box remotely using some of our own tools. And so we use a tool pretty extensively called NetExec. It used to be CME or CrackMap Exec, but that's been kind of abandoned. And now NetExec is the new hotness. And actually, it's a pretty fantastic Swiss Army knife tool. So if you're in penetration testing and you don't know about NetExec, run, don't walk, go find out. But what we could do is we could dump both the SAM and LSA registry hives. Do you want to talk about that?
Absolutely. So this is normally where we start getting with, what we can do to pivot off of this box. So we got admin permissions locally to this box. What can we find hidden in here? When we're dumping SAM, and when I say SAM, LSA, these are going to be registry hives that store credentials within memory. Sometimes EDR will come after us, and we'll talk about what we can do to prevent that. But while we're doing this, when we're dumping SAM, we are trying to get all of the NTLM hashes of all the local users on there. If we have an NTLM hash, we can pass it just as if it was a clear text password. And so what we'll go ahead and do, we'll see that we have an administrator NTLM hash here. We'll also see that we're dumping LSA, which is going to be more on the domain as far as credentials that are saved within that memory. And so we find a variety of different hashes this way through dumping LSA. We also find clear text credentials sometimes, which is amazing, especially when it's a domain admin. And so what we'll go ahead and use for this example though is, and we're keying in on that administrator NTLM hash that we dumped out of SAM, is we'll start performing an attack, like I mentioned earlier, past the hash. And what we want to do with this is we want to see if there's any password reuse when it comes to local admins on any of the other systems that are on the network. If we're able to get local admin to any of those, then it's just another opportunity to dump more passwords, more SAM dumping, more LSA dumping, and potentially lead us to the promised land of getting DA one day. And so as you can see here, we were able to get a few of our systems that if you see pwned on the right, and if you're a penetration tester, it's when you see that, you just get that super excited feeling inside you. Pwned means that you have that local admin permission. And so you can start performing those dumps of the stored credentials within memory. Let's see. Moving on. Oh, this is your part.
Yeah. So in this particular organization, they're running an EDR that would block a lot of things. So we could actually do an authentication against it, but outside of that power panel example, we actually couldn't dump LSA and SAM because of their EDR was blocking us. And so I've got just a whole tool bag of bypasses depending on what kind of EDR they've got. One that works on a lot of EDR products is if you either over like AT exec or WMI exec run Microsoft blessed tools that are built into Windows, you can often execute those remotely and not get blocked. And often you don't even get an alert on it. And so one of my favorite go-tos is if you're connecting to a server that is running Internet Information Service or a web server running web applications, they will often have app pools configured that with credentials. And so I'll run a tool called app CMD where you can actually list the configuration of the app pool into of each application pool that's configured on that host. And so if you hit every host that's running that with this app command, you can actually dump out clear text credentials. And what happens is a web application in your environment may often need to run with a specific level of permissions in order to access other resources on the network. And so you'll configure typically a service account into those app pools, and that service account only be able to do the things that it needs to do. But often we find, with a lot of organizations, they're configured way more than what they need to do. And I'd say I even hazard a guess that to probably 25 to 30% of the time, these credentials are domain administrator, because they're like, oh, the domain administrator access to that database. Let's just put that into the app pool. And so when we were able to dump that, we're now domain administrator. But in this case, this isn't what we did, is it? Because it didn't actually, we got some more credentials, but it didn't give us any more access in this organization than what we had already had by dumping the machine, LSA on that first box. So that LSA got us a machine account. This got us some low-level user credential that was actually limited. So what did we do next, Derek?
I think we turn our target to something else. And certificate authority, I know you and Matt's talk was just a little bit earlier and super interesting. That would normally be our next step, is to turn our target towards that.
Yeah. So in a lot of organizations nowadays, especially with hopefully NTLM is going away, right? You're switching to other authentication mechanisms, going to more PKI-based, Kerberos, and so forth. And we'll find often organizations are implementing PKI by implementing Microsoft Active Directory certificate services. And what this is basically a mechanism for managing your PKI infrastructure into your organization. And why are they important? CA is super important because it's like a principal that issues hall passes, right? So once you are given a certificate or allocated a certificate, you can use that certificate in a way that it's been allocated to be used in your organization. And the one that we want to hone in on today is authentication, right? So it's super important that if you're getting certificates issued by your certificate authority internally, if it's being issued with client authentication, you need to make sure that it's working appropriately. Because if you get a certificate, we'll go through some of this in a little bit, but often your certificate authority, you can get access to other resources that they didn't intend, your organization doesn't intend to give access to. So first of all, let's set this up. So what we're going to do here is called an NTLM relay. And so we should probably take a step back and understand, we keep talking about this thing at NTLM. And so there's NTLM hashes, which are basically password hashes that can be used directly in logging into other network resources. And then there's an NTLM V2 handshake, where basically when one network resource wants to authenticate against another network resource, it does a dance where basically, hey, it says, hey, I want to talk to you. I want to authenticate against you. And I'm like, cool, challenge. So I give you back a challenge, and you have to hash your password and the challenge and hash those together and then give me back the response. And I don't know your password, but I do know your password hash. And so we can do this little dance on the network and never pass the password across the network, but we can prove that you have the right password, I have the right password, and we can agree that we can log in and talk to each other. And so we're going to use a technique here called pettipotum. And so pettipotum is a vulnerability that was released in 2021, where it's a coercion technique where unauthenticated a user, a non-authenticated user could make a domain controller initiate this NTLM v2 handshake with me or with an attacker in order to relay that onto another resource. Whereas that's patched, what happens is that even if you're patched for pettipotum, there's a second version of pettipotum that's an authenticated based pettipotum, where if I can log in with a domain account, like we've got a couple now, right? We've got the app pool password. We also have the machine account from the power panel. We can actually use that credential to log into the domain controller to elicit that domain controller to connect back to us. And we can use that authentication to relay it onto another service in order to gain more access into this organization. And so this is our example of we connect we connect to the domain controller, get it to authenticate against us, and then we relay that on. And in this case, so we're using a tool called NTLM Relay X. So this is a tool that that is designed to do this three-way handshake or this handshake with the service. But what happens is when you connect to me and say, hey, I want to authenticate against you, I don't actually want to do that authentication. I want to authenticate against another service. So in this particular case, it's that Active Directory authority. And so what I'll do, you connect to me and I connect to it, and it's like, okay, here's the challenge that you need to authenticate against. And so I send that back to you. You do the hashing against it. You send that challenge response back. I send it over there, and certificate authority says, cool, you could get a certificate, because every Active Directory certificate services has templates, and typically the Active Directory, the domain controller authentication template is enabled by default, and it's not vulnerable to anything. But the issue is that since you say you've got either the web enrollment or RPC enrollment enabled with an escalation vulnerability, 8 or 11, I can now get the certificate of the domain controller just because you have Active Directory services web enrollment enabled. And so that's what we did in this particular case. Is we used that low-level credential to get a domain controller to talk to us, and then we get the certificate of the domain controller that then we can use to escalate our privileges in your organization. And so how the way that it works is, once the certificate is issued, we can actually do an authentication with a tool called Certify, where we give Certify this PFX file, this certificate that we were issued, and get the NTLM hash. And so that, like I said, that NTLM hash is just as good as the password when you're inside of an organization. And so once we have that NTLM hash, then we can actually use another tool called Secrets Dump. Go to the domain controller and say, hey, domain controller, I'm your buddy domain controller. I'm this other domain controller over here. I want to synchronize all the password hashes with you. And it will dutifully give you all the passwords for all the accounts in the domain, including domain administrators at that point. So that was the end of example number 2. Yep. So we went literally from access to a vulnerability in a power panel to then take that all the way through to dumping all the domain credentials in your entire environment. So that's bad, but it gets worse. Just wait. That's not all. The next example we've got was a credent login, the Mobile Guardian Shield. I'm not exactly sure what this thing is. I don't know if it was a mobile device management of some sort, but it was some kind of software that was installed on this client network that when we scanned the host, it was running a web service for whatever this credent tool was, but it also had a Java remote method invocation port open, so port 1099. So basically, what RMI is it's a Java component to a web application server that if you're running it and allowing it on the network, it can be by default or misconfigured, where I can, as an attacker, gain access to run code that's already running, that's already on your server. And so in this particular case, we enumerated everything in the RMI interface. We found several vulnerabilities. And so once we find that this is a vulnerable RMI interface, we can start wanting to run our own, or not our own code, but code that's already running on the server. And so we figured out that this credent web application was actually a Spring-based web application. Anybody in here doing Java development or know much about Java web applications? Spring is a framework that a lot of applications are written in, and so whereas your developers could develop everything from the ground up, they'll often use a web framework to make creating the web application quicker and easier to use. And so in this particular case, since we discovered it was running a Spring-based web application, we used a tool called WISO Serial, which is basically a gadget interface that basically says, okay, if you're running this kind of a framework, if you're like Spring framework on the application, I know what I can send to the classes to run whatever program you want. Or say you're running Commons collections, or it actually has just a giant catalog of, if you're running these Java classes, it knows how to basically run whatever command you want by using those classes that are already loaded on the system to run the commands that we want to run. And so in our particular case here, it was pretty blind. And in fact, the first thing that I did was to test out proof of concept was I said, okay, ping my attacker IP. And so I ran Wireshark or TCP dump, and I said, just look for ICMP from this host. And when I said, okay, ping my IP, I got pings back. which means I knew I had remote code execution on the box. And once you have remote code execution, then you can do anything that service can do as the user it's running as. And often these applications are run as a local administrator or some kind of an administrative privilege. So in this particular case, blindly, we did like what we did before. We were like, let's create a local administrator account. So we created a local administrator account. We added to the local administrators group. We didn't actually know, we didn't get any feedback to know if this worked. So then we used our trusty NXT tool and we logged in with that LMG account. And at the bottom, you'll see that pwned again, which means not only did that code execute, but it had the permission in order to be able to add a local account to that system. So once we added that local account to the system, then we went back to our typical technique, right? So remotely we'll dump the SAM, we'll dump the LSA. But this time in LSA, there's a service that was running on the box that used a domain administrator account. So actually at this point, it was like game over. We had direct domain administrator access because the service account or a service on that machine was being run as a domain administrator account. And that was a game over for yet again.
Absolutely. Scary. But not as scary as this next one coming up.
Yeah. So
this is the worst.
So this frustrates me a lot. So who's watching the watcher, right? And the reason why this really frustrates me is because sometimes the security tools that we're installing to protect our networks are the vulnerability. In this particular case, we're on an organization's network, and we were scanning hosts, and we found this web interface that was a SecureWorks web interface. There was their enterprise agent for Windows. So there's actually a custom branded version of what's called Snare. And it was very clear to me, if you look in the upper right-hand corner, it's hard to see, but it's like your license expired in 2020 in August, right? We just did this test 8 months ago. So clearly this is software, and literally we scanned the entire network, and this is the only instance of this software that we found. So likely what happened is they were probably a SecureWorks customer. They are no longer a SecureWorks customer, and they uninstalled this web interface or this agent from every server or in every computer on their network, except they missed one. And so this is the server that they missed, and we found it. And by default, it's mainly a read-only interface, but it was unauthenticated. So literally by having this installed on your network, it's actually a vulnerability, and I'm going to show you why. So this is the page that we're looking at right here is the heartbeat configuration, log configuration page. And you see here, there's an option for export the heartbeats to a file. And by default, that file is supposed to be C snare/heartbeat. I said, well, what if it wasn't C:? What if it was my attacker IP, /snare? And so I literally was able, I checkmarked the box, I changed it to my attacking host, and I hit apply changes. You know what happened? I got an NTLM handshake. So that machine now, as the user that was running Snare, would do that NTLM handshake to me that then I could relay on to another service. You want to tell them what service relayed to?
Yeah, and honestly, this is one of my favorite ones. I feel like it's the most neglected when it comes to security controls. LDAP, that is the protocol that we're going after. And just to briefly go over LDAP, it's a lightweight directory access protocol. Think of this protocol as basically a virtual phone book for network resources that will essentially allow different applications to get information about verifying users from one central place. So it knows it has to go directly to LDAP, and LDAP will provide that information. Okay. So LDAP, it'll also contain usernames, passwords, other attributes commonly used for user authentication. So it's very juicy whenever you hit it right. Whenever you get in and you're able to authenticate to it, you can actually, we'll go ahead and show in the next slide, get an LDAP relay. With the LDAP relay, there's several things that you can do, but what we're wanting to do is kind of like what Tom was saying earlier. We want to relay that NTLM handshake over to LDAP. so that we can make that connection and we can log into LDAP. Once we log into LDAP, we can do basically what a standard user account can do if they're able to log into LDAP. And just for fun, this is for a shot glass. Who knows what a standard user account can do, or maybe what we might want to do if we do get that interactive shell with LDAP and we're able to log in. What was that? Yes, that's one of them. We can enumerate information.
You get a shot glass. Who said that over there? Thank you. Query the domain. Yeah, they enumerate the domain. What else can a regular user account do? Anybody know?
Yeah, I'll give you a hint. If you went to Tom and Matt's talk an hour ago, the answer was said. What was that?
What? No, it can create a computer account. So what happens is that a standard user can create a computer account, create a new object in the domain. Does anybody know by default how many computer accounts can be created? 10.
Perfect.
I saw 10. I saw 10 fingers right there. Here you go. I don't have a professional football. That's why I do computers, because I can't throw.
It's my favorite thing, watching Tom throw things.
Yeah. Derek's better. He should throw.
But absolutely right. So what we want to do is we want to create ourselves an account so that we can log in. We don't have to relay anything anymore. Now we can just log in with our own username and password. So we'll create our LMG machine account. And I think on the next slide, this is where you'll see the interactive shell. Now we can't create this on just regular LDAP. We do have to upgrade it to LDAP S, the secure encrypted version of LDAP. So that's where we'll see this command start TLS. That puts us authenticated to LDAP S. And what I find really interesting, Tom, and you might be able to explain this even further, is if even you have the security controls set up on LDAP S, which is binding required, we can circumvent that by establishing a LDAP shell, which is LDAP, and then upgrading it through this technique.
Yeah, so if you don't have signing enabled on LDAP and you have channel binding, so we'll see this often where they may have one or the other and not both. I like to go to LDAP instead of LDAP S because often it's been enabled because you've got some legacy piece of software that needs to talk LDAP. And often you're not talking LDAP S, you're not doing SASL, you're not doing any of the advanced encryption techniques. For some reason, the thing that needs to talk to LDAP needs to talk unencrypted. And so often it's configured very weakly to enable any user to log in as LDAP. And then you can upgrade that to an encrypted version of the LDAP connection via the unencrypted port.
Absolutely. And so now we're able to authenticate to the domain. We have our machine account. We can authenticate. Lots of things that we can do at this point. One thing being that we can start, and I think it's on the next slide, we can start querying different templates that might be under the certificate authority. We can start looking for misconfigurations or vulnerabilities that we can continue to exploit through our attack chain. Right here, you see certify again. This is where we're actually dumping and enumerating the certificate templates. The certificate authorities may even be vulnerable. And so we're able to also see which ones are enabled so we don't waste our time on any that might have been disabled, you know. But essentially in this case, we were able to find a vulnerable instance of a certificate. And this was this is probably one of the most straightforward ones, I would say, escalation 1.
Yeah.
And this is just a little highlight of why it's vulnerable. And Tom, your talk, you spoke a little bit about this, but the enrollee being enabled enrollee subject, definitely part of that vulnerability with it being the misconfiguration that creates this as such a dangerous exploit. And all we need is just an authenticated user. So let's rewind real quick. We have an authenticated user because we just got done creating a machine account, right? So in my opinion, I think this exploit would work. And escalation 1 says any authenticated user can request a certificate for any other authenticated user. That sounds like maybe a good attack path to get to DA. I don't know.
Pretty bad.
And so we go ahead and we push through this. We push through as far as dumping the domain admin NTLM password hash. And really, this is the only other command that we run in order to get this. It's a pretty straightforward exploit. We figure out exactly what the vulnerable template is. We provide that template name, and then we provide the subject.
Yeah, so when we enumerated LDAP, we know who the domain admins are, right? So we know who it is that we want to emulate. So we can see, okay, if we can go and assume the identity of any user we want, we know a user that's really important on your network. So we'll go and we'll emulate that, or we'll request a certificate for that domain administrator account. And then we'll be able to retrieve the NTLM hash because we'll be able to authenticate with that certificate and get that NTLM hash directly from the domain. And once we have that, we can then become the domain administrator without actually even knowing their password.
Oh, don't even have to waste time on that. We can just pass the hash just similar as we did in the past, and we can authenticate, and we'll get that fun little pwned right next to the DC.
And so then with that domain administrator hash, we can go to the domain controller and request to dump the ntds.dit directly from the domain controller, which gives us the NTLM hashes for every user in the organization. And we can take those password hashes, take them offline, we can crack them, we can authenticate as those users against other resources in the network and completely be able to take over your entire organization.
And sometimes this is really important information for our clients. Even though we just got done taking over their entire domain, that hurts. But now we can start putting all these NTLM password hashes into our cracker to see what weak passwords exist on their domain, which
exactly.
I've talked to a lot of clients that really valued that, just because they're able to find those, those machine accounts that have, welcome 123 on them from 10, 15 years ago. They're able to zero in on them.
Yeah, we actually, one of our coworkers, Emily Gosney, is amazing. She actually used to run a company where they created password crackers, and her team has won the password cracking at DEF CON for a decade now, every year. And within about 4 to 8 hours, we're typically successful at about cracking 80% of the passwords for most corporate networks that we test. And so it's kind of scary, right? So when we say, hey, you should have a 25 character password on your service accounts, we mean it, because these things can be cracked so easily nowadays with all the GPU powers. Now, especially with so many GPUs flooding the market for LLMs and everything else. Password cracking is a way that once you get these hashes, you can get all the passwords, and you can do things like password stuffing attacks, right? How many of your users you think use the same password on the domain that they use on their Facebook account or their banking account or anything else? And so this is why helping your users understand password hygiene and using good, long, secure passwords is important. And that's it. I think we've come to the end of our talk. Are there any questions? Yeah. Yeah, so the domain controller is running LDAP. And so what we're doing is we're acting as a relay. So we'll use NTLM Relay X to listen on 445. So then when we get that NTLM connection to us, we actually do a protocol change. And so we'll then connect to the LDAP service to get its challenge and send that back. So we're actually facilitating a protocol change between SMB and LDAP, and then do that handshake. And then we actually, I love putting NTLM Relay X into an interactive shell so that you can do multiple things at one time. You can dump the domain information. You can try to create a computer account. You can even do some role-based access permission changes depending on who's connected to you. Sometimes we'll get a relay on a user account that's a domain admin, and then we'll be able to create our own domain admin directly. So it's so we're basically kind of jumping into that middle of that connection. And then once we have that authenticated LDAP session, our tool knows how to talk LDAP to do querying, how to create users, how to modify rights, and things like that. So I recommend always disable LDAP and on LDAP S, enable channel binding. So you can't do that man-in-the-middle attack. Yeah, right here. So the question is when we did this LDAP attack, did we do this externally? Did they allow SMB off the network? The answer is it depends. We don't typically test that way. So when we do an internal penetration test of an organization, we typically, what we'll do is we'll send you a box or have you spin up a VM on your network in like a user segment or plug in our box like into a conference room. And so then that machine will connect out to our infrastructure and allowing our users to pivot back into your organization and do this testing. But what Trent is getting at here is often what we will see is that organizations allow any traffic from an end user device out to the internet on any port you want. And so we'll send, if we do an external penetration test, we actually often send an email to users in the organization with a UNC path as an image file to see, will they do an NTLM handshake with us across the internet? And the answer often is yes. And in an external test, we'll get that NTLM V2 handshake and we'll go and try to crack that offline and then see, hey, do they have a VPN exposed that now we have a username and password for, and then try to turn an external test essentially into an internal test if we can authenticate against their VPN servers. Any other questions? Well, thank you so much for, oh yeah, right here. Is that a question? All right, sorry. Thank you so much for your time today. Yeah, go ahead. So the first CyberPower, not fixed. Second CyberPower was fixed. Our client didn't have a patch for it. And it was, like I said, it was within a 1-year-old patch. So how often you patch your Internet of Things infrastructure. And that's what they were, vulnerable to, is that, it's like you're patching your Windows hosts, right? You're patching the things that have automatic patching, but things like your printers often don't have automatic patching. CyberPower doesn't have automatic patching. So, being on top of it, having a good patch management program, looking at was this a big vulnerability? It's at least a medium vulnerability, but that coupled with what we could do with that vulnerability turned it into a critical finding, right? And that's what we're after, is that with our penetration testing, we're not just looking at a vulnerability saying, hey, you got this vulnerability and that vulnerability and that vulnerability. We're trying to chain multiple vulnerabilities together to come up with a critical finding and something that's actionable and meaningful to your organization. Like if I popped a box and actually give me access to anything, like say they got root on a camera, what's that going to necessarily give me? Not necessarily anything, but where it's important, it's not a critical finding, right? It's an important thing to fix on your network. It's not going to end in ransomware potentially. So, well, thank you so much for your time today, and I hope we didn't scare you too much.
Thanks, everyone.